All right, guys at home, worst thing about hybrid model is forgetting to press record, which I did. So I'm running through this a second time, so I'm gonna be a little crabby. But not too crabby. Yes, just give me just a minute. So somebody just asked, are we going to get our tests back? And that's the first thing I talk to them about is make sure you hit this test reflection Google form so you can see what it says about what can or can't be done. There's a little video that explains it. So that's first step. We're moving into a chapter that's called techniques, or it's actually called advanced techniques of integration in our book. It's chapter 8. We are going to be not only using all the ones you know to date, like U-sub and the power rule and natural log and all that good stuff, but we're also going to add about 4 or 5 more techniques to the mix. So it's really important that we know how to do the ones you were already taught in AB. So we're going to spend a couple days on that, and then we spend a good 2-3 weeks learning more ways to integrate. And like I was telling the guys in class, integration is more difficult than derivation because like if you have a quotient and you're taking a derivative, you know to use the quotient rule. If you have a quotient and you're integrating, it depends. So I'm just going to cruise through this a little faster than I did with them. All right, so most likely to appear on the AP exam would be obviously our power rule, that we add 1 to the power and we divide by that power, and we always remember our constant of integration. Another one that happens a lot, especially when we have denominators, is knowing that our 1 over u du can pass off to the natural log of the absolute value. What's that? I did. Bodeheimer's phone's going off. He thinks he has friends. It's his mom. Just kidding, Blakey. He's crying. All right, where was I? Oh, I said to be careful though when it's set up in that sort of form that now that you're good at it, that you don't cut too many corners unless you're 100% sure you're doing it correctly. What I oftentimes see with this one is kids passing right off to the natural log and saying this red expression is the answer. Where remember, if this is your u choice in the denominator, yeah, the 5 can come out front. Yes, you have 1 over u, but you have to generate the dx. So if your u is 2 minus 3x, your du is negative 3 dx. So make sure you have that negative 1/3 that comes out front. So watch out with that. The other one is our e to the u, and again, you have to generate that dx in terms of du. These are our big ones. We also have the one from Friday that passes off to arctan. That I see on the AP test more than the other inverse trig ones. Remember, it's 1 over analysis, arctan urine analysis plus Carl. Then the trig ones that you need to know, obviously, are sine, cosine, St. Cloud, St., negative Cloud, St. Remember, we derive it this way, we integrate that way, so this gives us all our sine and cosine antiderivatives, but we also need to know secant squareds. The derivative of what is secant squared? The answer to that is tangent. We also need to know secant tangent, and again, when you're finding an antiderivative, you're saying the derivative of this is that. The antiderivative of secant tangent is just secant. And then again, be very careful with the u du issue. Less likely to occur, but possible, are things that maybe require long division. I think there's 1 or 2 in the mega integration packet, right? So they may or may not require long division. Remember, that's an option when the degree on the numerator is less than or equal to the degree in the denominator. Also, when everything else fails and it's polynomially, try long division. It doesn't work very often, but we did it last year. The other one is the complete the square issue that happened, I think, on Friday's notes, where you have something that in your face maybe doesn't look Pythagorean or like you have the a squared plus u squared that passes off to arctan. But if you complete the square on this, it does, right? And I did that in the notes on Friday, so I'm not going to repeat that. And then if anything pops up, we will maybe add them to this, both to the occurs a lot. By the way, U sub's king, always try that first. All right, so then we went and did some examples, but we didn't do all of them. We talked through this one, and I said U sub is king, so let's start with that. This would then be U to the fifth. Just don't forget your du is 4 dx. So don't forget that that dx gets replaced with 1/4 du. So you'd have 1/4 u to the fifth du, and you'd go from there. We talked about how number 2 looked very arctanny, except it's got that root there. So it's not falling into the normal models, but u sub is king. So when u is x squared plus 4, I'm sitting there with a root u. And my du is generating a multiple of the rest of the integral. With a simple 1/2 correction, I get to replace this guy with a half du. And then I'm passing off to the power rule. And if you're sitting there thinking, oh, she's going so fast, we did this all last year. It's technically not part of this chapter. We're just trying to work out some kinks before we learn new stuff. When we got to this one, I walked around the room. And I just happened to walk over to the left-hand side. And I said, if you don't know how to start it, you're going to be stuck. I said, the most common wrong answer is people thinking that's a secant squared, because that's what the derivative of tangent is. But the antiderivative of tangent is not secant squared. So someone wrote it like this. And I said, yes, you are on the right track. When you don't know, you need to play. And this would be called on the worksheet using like a simple trig identity or a simple algebra move to get started. Now, my u can be the denominator. Remember, when you let u be the denominator, you're invariably trying to get that 1/u du. The derivative of cosine is negative sine. Don't forget the derivative of the guts with the chain rule, so that'd make another negative 5, so it'd make it positive. So to create the rest of this integrand, we need a 1/5 du. All right? And then you would go from there. All right, I'm not going to finish that one off either. Similarly over here, I would see my u choice being 1 minus 5x squared. And then I just asked them, I said, well, is this e to the u du or does it need a correction? And they said it needed a correction. I said, of what? And somebody said of negative 1/10. And this A group is just on fire with integrating today. So we didn't finish that one off either. We went to the next page. And we talked about number 5. And I told them to get that 6 out of the way, not because you have to, not even because most people do, but because I think it helps unmuddle that integrand. So now it looks like a lot of perfect squares in there. And I asked the kids, I said, what does this look like? And they said arctanny. And it does. So it does look like I can write it as 1/a squared plus u squared, right? Now just be careful with that, because your a is 5, your u is 2x, but again, this dx needs to be generated. Du is 2 dx. So the dx actually has to be replaced with a 1/2 du. So just be a little careful with how much of it you do in your head. So when we're all done, we have the 6 from the top of the fraction. We have 1 / analysis. Oh, is it time to go? No? Okay, because I do have to give their test back. I'm not gonna, this would be arctan u/a. And don't forget the fraction correction as well. So we have the 6 out front, we have 1/a, we have a fraction correction, and then we have arctan u/a. All of this from last year. All right? So then, what we did is I went and talked to them about the worksheet. So you guys should all access worksheet number 2. And I said, I tried to remember what last year their questions were. In the first page, some of them didn't understand the directions. In each row, there's one that can be done with U substitution, one that can be done with simple algebra or trig identity, or just by altering the integram a little bit, one where nothing's needed, and one that can't be done with techniques of Calc 1. So in row A, nothing is needed for the first one. That goes right to the power rule. You don't need to fart around with it at all. And then you have to do it. The second one over would be U sub. So you could just write U sub. U would be x cubed plus 1. Then you do your du. You'd work it on out. There's a key, by the way. You should get stuck on the third one over. The square root of x cubed plus 1, with techniques of Calc 1, we cannot do yet. And the last one, if you FOIL it, or use an algebra technique, you can do it. So in each row, there's a nothing, a U sub, can't be done, and some sort of simple manipulation. Okay? So, by the way, sometimes what it looks like it is, isn't what it is. So if you look in row B, the very last one over, it looks arc-sine, but it's actually U sub, that x over the square root of 1 minus x squared. So just, I caution them to be careful. Then we went and looked at, from last year, the kids struggled with number 29. But I tried to prevent that issue this year. So on number 29, U sub fails. Does have an ugly root. And then I think Catherine said, complete the square. I was like, yep. So that was a complete the square one. It'll pass off to, and they said arc-sine, and it does. So on 29, you got it once you write it out. What was the, 22. If you were to try U sub, it fails. You could try factor canceling, but nothing cancels. So you seem stuck, unless you remember, and then that's when I think you, Emily, say long division. So when the degree of the numerator is greater than or equal to that in the denominator, you can try natural log. So I told them that we're working on this for the next couple days, along with the test correction for some people. So you need to look at that test reflection slide. Tomorrow, we're going to talk a little bit about 44 to 49. So that's actually our big test tomorrow, is to remember how to integrate by separation of variables. All right, so today and tomorrow, I think I had on the slide, this is due in full by Sunday, mainly because some people have some tests to fix as well. So I'm done. You'll get your test back tomorrow, my beaten, and